Hello everyone and welcome to my YouTube channel. Today we are going to build an end-to-end agentic AI application with the help of Microsoft Agent Framework. So Microsoft Agent Framework, also known as MEF, which is a recent release from the Microsoft in the last month itself. So we'll be leveraging this agentic AI framework in order to build a multi-agent application. As you can see on my screen, we are going to build an smart home energy saver application. So basically this application is going to generate a optimization plan in order to save your energy cost. And it will suggest few recommendations. Basically it's a multi-agent system. So it is not only, so it is not a simple use case that we are covering. So it is a real-time industry application that I have tried to mimic itself, and it is not only using the agentic or generative AI capability, but it also takes care of a machine learning part as well. So basically we have trained a machine learning model in order to optimize the energy first, and then on top of that machine learning models we have agents which are collaborating and understanding how exactly we can go ahead and save the energy for your personalized home. So we'll go deep into that, how exactly we have built the application. We'll talk more about the technology that we have used when we'll go ahead with the architecture diagram. But for now, let's quickly go ahead and test the application. Let me go ahead and rerun the application quickly. So refresh it. So first input that we need to pass is the household size. So this meaning the number of people living in the house. So let's go ahead and select 5. Then appliances, currently I have fixed the appliances categories, like we are using air conditioning, washing machine, dishwasher, heater and computer. We can go ahead and change these categories later on. For now, that's fine. Let's move ahead. So location, I have added Pune as a default location. You can change this location to any another location. Currently I'm living in Pune, so that's why I have selected Pune. Then time zone, obviously it's Asia. Now tariff rates, so somewhere I'm selecting it around 10. I'm not sure about the exact tariff rates, but we can check that later. Now peak hours, let's go ahead and select 8.5, meaning so this is the peak hour rate energy consumption. So these rates are in rupees per kilowatt hour, meaning per unit basically. And peak of hour meaning generally the late night where the energy consumption rates are low. Again, this we can go ahead and check it out later. Then peak start, let me select, let's say our peak starts around 9 in the morning and peak ends around 10 in the evening. So that's what we have selected. Now email, let me go ahead and add my email. And user, let me select me as a user. So we have given all the input parameters that are required for our custom home appliance. So let's go ahead and generate the optimized plan. Okay, so you can see it has picked the location as Pune city. So basically it will go ahead and hit to the weather forecast API. So the one of the agent that we have built, which is responsible to identify the weather forecast. So based on the tomorrow's condition, that is going to be the weather condition and the temperature, it will go ahead and recommend the plan. Also, there are other parameters, like it will use the machine learning model in order to identify the energy protection. We'll see all those details. But okay, if you go down and see, so the current recommendations, it is saying you can save close to 2 units per day. So total energy saving in a day is close to 18 rupees. And then if you see the recommendations, set to 26 degrees Celsius AC and restrict the use between 10 a.m. to 4 p.m. only. It is recommending to use in this range only. Use only if necessary, since temperatures are significantly lower than the previous usage. So in the Pune, the temperature has been dropped since last 2 days. So that's where it is recommending. And the estimated cost saving is close to 15 rupees. Now washing machine, schedule for late evening after 9 p.m. when the energy rates may be lower, but stick to the quick mode as usual. And again, for us the peak ends around 22, and I don't think there are any differences between these units as such. So that's fine in these rates as such. So that's where it is saying that estimated cost is 0, because again we are in the peak area only. We are in the peak timing only. Similarly for the dishwasher, run it during peak of hours in order to save, but currently we are not in the peak hour, so that's where it has selected 0. Then appliance heater, so postpone use as evening temperatures will be low, 13.6 degrees Celsius, unless the house is too cold. Consider setting it to lower and comfortable temperature. Again, we cannot save much here because the temperature in Pune has drastically dropped. Then computer, you can save it by considering or shutting down or reducing the active use time in the afternoon. So those are the recommendations that are generated. Again, there are room for improvement, and definitely we can do that. This is just one sample project that we have built in order to see. So the energy saving is close to 20 rupees. In a month, you can save up to 600 rupees. So that's the energy saving plan that it has given. Now, if you want to check it for another location, so let's go ahead and select Mumbai. You will see some differences in Mumbai. Tariff rates, let me reduce it to, let's say, 9. Off-peak rate, that's 8.5. Now, peak starts in the Mumbai, peak starts around, let's say, 7 in the AM and 11 in the night. These details, other details will keep it same, and household size, let me reduce it to 2. Now, let's go ahead and generate the recommendation plan and we'll see. Now this time again, you can see it has picked the location as Mumbai, and it will identify the weather forecast for Mumbai, what's going to be my weather condition tomorrow, and based on that, it will suggest the recommendations. Okay, you can see the energy saving plan. So air conditioning recommendation set to 26 degrees Celsius and instead of 25 during peak hours. So 25, it has picked it from the previous usage because I have added one file where we have given the yesterday's information, what was my settings yesterday. It has given these details and use it in this particular period where we can save close to 16 rupees. In washing machine, schedule laundry of peak hours. So schedule off peak hours in the evening. So it has given close to 0.45 rupees we can save. Similarly for dishwasher, use it in the late night. So next one is for computer, use it during the high demand hours 9 a.m. to 6 p.m. where you can save close to 2.25. And this is the main factor, heater. Postpone the heater usage as the forecasted temperature do not warrant heating. As we have selected Mumbai, obviously Mumbai is hotter than Pune, and that's where it has selected that, okay, there is high energy saving possible, close to 31 rupees you can save. So the total recommendation that it has generated in a day, you can save close to 50 rupees, which is close to 1500 a month. So that's the recommendation that it has generated, and you can save close to 5.6 units. So isn't it interesting? So this is again a project that we have tried to build. There is room for improvement, obviously. And the purpose here is to go ahead and build the application, see how exactly you can build the agentic AI application in the organization, and how exactly you can build this real-time project. So without wasting time now, let's go ahead and straight jump onto the architecture. We'll go ahead and explore the architecture that we have built. So let me go ahead and open the architecture. Okay, so let me go ahead and walk you through the application that we have built. So this is the logical architecture. So let's go ahead and see. So as you can see, we'll be using this Microsoft Agent Framework and the Azure AI Foundry in order to, where we have hosted our GPT-4o model. That's what we are going to use it as a large language model. Then you can see we have built two agents. First one is the energy usage analysis agent. Second one is the energy optimizer agent. And there is third agent, which is used in order to send out an email. Okay, I forgot to tell you about sending an email. Let's say once this plan is done, you can go ahead and send out an email by clicking here. So it will go ahead and generate the report, and that report it will go ahead and send out to over your email. Now the plan here is in the real industry, you can tag these particular recommendation settings to your, or you can integrate this recommendation setting to your IoT device so that your IoT device will go ahead and adjust these settings. Let's say for AC, it will go ahead and set the temperature to 26 degrees Celsius from this particular period, and it will help you save your energy automatically. So let me go ahead and see it has sent the email. So let me refresh it. Okay, you can see I have received this particular email 0 minutes ago recently, and this is the weather forecast information that it has given. That's how I can go ahead and save the energy, and you can see best regards from Home Energy Saver AI agent. So now, as we cannot connect here to the IoT devices, we don't have that setups available. So as it is not feasible for us to do it now, that's where we have automated it by sending the automation report. So assume that once we send this automation report, the IoT devices will pick these settings and it will apply those settings to your home appliances. So that's the idea basically. Now, okay, coming back to our reporting, coming back to our logical architecture. So the first part, as you can see, open source past energy consumption data. So I have picked up a Kaggle dataset related to the home appliance energy saver. So there was one competition held at Google, from where I have picked this particular data set. I'll show you that data set. That data set I'll be using in order to train a machine learning model. And that machine learning model, we have used it as a Facebook Prophet model. in order to find out the forecast energy. So basically this model will identify the next day energy forecast in kilowatt hour. That we are passing it to our Microsoft Agent 1. That is your energy usage analysis agent. And this prediction, we have added it as a part of tools. The second part we have is the tomorrow's weather forecast. So remember, we are selecting a location. So based on that location, we have a weather forecast API, which is hitting to that API and identifying what is the weather condition, what is going to be the weather condition in that location for the next day, and that information it is passing. And again, we have built it as part of tools. And the third information that we are passing is the yesterday's energy consumption. So we are maintaining a one Excel or CSV under which we are putting all these information, like what was my settings that I used yesterday. So the recommendation that we have used is setting to 26 degrees Celsius from this particular peak hours. This information will be utilized tomorrow. So that is what we have given as part of this particular file, and then it will compare all these three analysis. It will do the analysis, and there is a to a conversation that is happening, agent to agent conversation. It will pass that information with a standard protocol to the second agent. So we have built this particular standard protocol, and the second agent is the energy optimizer agent, which will go ahead and use the yesterday's usage, tomorrow's weather forecast, machine learning predicted energy forecast, and then it will generate the estimated energy saving plan now. And that is what is available on the user interface. Now if we go deep dive into this, so what exactly details we are passing? So this is what we are passing for our first agent. We are passing the household size, appliances we are passing, air conditioning, microwave, computer, etc. Then location we are passing. So whenever we are passing the location, it is picking the latitude and longitude in order to understand for the weather forecast what's going to be the weather at that particular coordinate location. Then time zone we are passing, peak rate, off peak rate, tariff, all this information we have selected on the user interface. That's what we are passing to the agent first. Agent first is going to generate the response and will hand over that response to the agent 2. Now how exactly we are passing these individual information, let's go ahead and deep dive into that. First of all, let's talk about the machine learning model that we have built. So for the machine learning model, we need to pass a air appliance that we are using, let's say air conditioning, then date. Let's say we have passed one particular date, so that it knows what was the weather condition at that particular date, the average temperature that we have passed, household size, and whether it is a weekend or not. That information we have passed as an input for our machine learning model. And machine learning model is going to predict the next day energy consumption. So here, let's say it has predicted 1.2 kilowatt hour, meaning 1.2 units. So that's the purpose of this machine learning model. Taking these particular input, it is recommending what is going to be my forecasted energy for the next day. And from where we are getting these information, again we are getting these information based on the weather forecast that we are doing. Okay, next, coming to the weather forecast. So for tomorrow's weather forecast, we need to pass the latitude, longitude, the coordinate location, and then the time zone. So once we pass this information, it goes ahead and identifies the minimum temperature that's going to be tomorrow, maximum temperature, and the weather code. Weather code, nothing but like what's going to be my weather condition, whether it is going to be cloudy, clear, sunny, all that information it will provide. So the first model is identifying the energy prediction. The second function that we have written, which is identifying the weather condition, that's what we have seen. And the third one is the uh, energy consumption. So we are passing the last use date, and for that last use date, what exactly it is giving is the date format and the usage. Let's say the latest records, start time, end time for each appliances. So let's say if you are using air conditioning, what was my last date when I used the air conditioning, what was the start time, end time, what was the temperature, all that information we are giving. And all these three information is going to our Microsoft Agent 1, Microsoft Agent Framework Agent 1. And this agent is calculating the response in this particular format. So if you see, the first agent is generating what is my last usage date. So let's say this is my last usage date. Based on that, it is finding out the yesterday's usage. So yesterday's or last usage date, last usage. So for that last usage, we use, let's say, air conditioning. So for air conditioning, this was my start time, end time, mode was cooling. This was the energy that it has consumed, average temperature, the weather condition, average temperature meaning the temperature on that day when we uh, utilize the air conditioning. Then weather condition, it was hot. Then weather date, it is picking the weather date. For this particular date, we are doing the forecasting. Let's say we are running this application on 11th. So last it the application last the appliance we used on, let's say 8 or let's say 9 or 10. And then for the next day, it is calculating the weather forecast. You can see it is identifying the next temperature, what's going to be the temperature, partly cloud, what's going to be the weather condition, let's say partly cloud. And this is going to be my second output that it is going to generate. And then the ML forecast for each appliance, let's say air conditioning, this is my predicted unit of consumption. Similarly, for all other appliances, it is calculating the consumption energy. And this it is calculating based on the machine learning model that we have trained. We'll talk about each and every detail, how exactly which data set we have used and how we have used the FB profit model in order to train this machine learning model, and why it is generating these ML forecast. We'll be seeing that end to end. Now, this particular is nothing but our protocol that the agent is generating response. Now, we have make sure that the agent should generate the response in this particular format only, because our next agent accept that particular format. So that's the protocol that we have built, and then we are giving that input to this second agent called energy optimizer agent. Now this optimizer agent, as you can see, it is taking into consideration the yesterday's usage, the tomorrow's weather forecast, the predicted machine learning forecast for the energy, and then it is giving the recommendations for the energy saving. And these recommendations are in this particular format, the final recommendations. You can see summary. Tomorrow it will be hotter than average, 34 degrees Celsius. This is what it will generate. Again, it is based on the forecast that is generated based on the weather forecast API. And actions it will generate for each appliance. For air conditioning, the recommendation is to set 26 degree between, let's say, this particular range. This is just an example. Estimated cost saving is, let's say, 1.3 and 1.3 unit, and estimated cost saving in rupees, it is, let's say, 14.5 INR. So it is generating again the response in this particular JSON format. That is what the protocol that we are following, because our user interface accept, or the API that we have built accepts the response in this format, so that we can showcase that response in this particular format for the UI. So that's how we have followed a proper standard practices in order to build the response, because that's what the industries are using. And that's how you can control the hallucination of your model, or you can control how exactly your agent is generating the response. It should not generate the response which is not consumable. So that is what it is generating, and that's how we are able to achieve these particular responses. Now, so we are going to see these tips in detail, and we'll be understanding how exactly these agents are collaborating and communicating with each other and generating these final responses. So now we are aware about the complete project picture, how exactly we are going to build this application. Now it's time to start coding this particular application. So without wasting time, let's straight jump onto the coding section. Okay, so I have opened my Visual Studio Code, and we have created this particular folder, Smart Home Energy Saver. So let's go ahead and start generating the files. So first of all, let's go ahead and create a virtual environment. So to create the virtual environment, let's use python-m virtual environment.venv. This is the virtual environment that we'll use. Okay, you can see it is creating the virtual environment. So meanwhile, let me go ahead and create the requirements.txt. Okay, also let me create the .env to save the environment variables. Now, so let me go ahead and add the requirements. Okay, so we'll be using these many requirements, like we have core dependencies like NumPy, Pandas, Python. Then we have machine learning, Python data utils. Then we have machine learning and feature engineering, like we have scikit-learn. Initially, I tried LightGBM, XGBoost, but yeah, we'll see that like these are not required as such, but we can keep them. Then we have matplotlib, Profit, and plotly. Again, Profit will be using. So let me add it here itself, because we'll be using Profit. So initially, I tried a couple of machine learning models, and I was not getting good accuracy. That's where later on I switched to Profit. That's where these are the installation. That's where I've installed these dependencies, but that's fine. You can go ahead and skip these, at least these two models and the TensorFlow. Okay. Then for the visualization, we'll be using matplotlib plotly. Then for running the Then for building the backend application, we'll be using Fast API, and that's where the UVCon is required. Then for building the agent framework, we'll be using agent framework, which is from Microsoft Agent, and OpenAI is the indirect dependency. Then again, this part is not required, blob storage. Basically, if time permits, we will go ahead and upload the informations to the blob storage. So just like a real industry project, we'll try to consume the models from blob storage. But again, it is based on the time constraint. So let's keep it that. Then we have Pydantic models that will be using python.env in order to load the environments. And for the optimizations, we have used the Optona library and then the Streamlit. Again, these are the indirect dependencies that we have installed. Again, Streamlit in order to host the user interface. So these are the dependencies that we have installed. So in the environment, we'll be using an Azure OpenAI endpoint. So let's go ahead and pick those environment configs. So, okay. We need Azure OpenAI endpoint and the Azure OpenAI chat deployment names. Okay, so let me show you from where I have grabbed these information. So let's go to Azure. So go to portal.azure.com and log in with your email ID. So I have already created one subscription. So if you have not created, go ahead and create the subscription. So this part, you can either use a Azure OpenAI model, or you can use any open source model that you would like to. You need to just change the configuration in the code. And I'll talk about that configuration whenever we'll cover that part. But for me, as we are sticking to the real industry practices, that's where I've selected Azure. And that's where we are using a paid model from Azure. Then, but yeah, for your practice, you can definitely go ahead and use any model. That's fine. So then I have created a Azure AI Foundry service. So if you are new to the Azure AI Foundry service, I would recommend go ahead and check out the links. I have already covered all those details in my YouTube channel as well as on my Udemy courses. So you will find the link in the description below. Now, in order to create this service, again, you just need to use this service. Then you can go ahead and create a resource. You need to add your subscription. You can create a resource group or select the existing one. You need to give the project name. You need to select next, 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 and it will create the service for you. Then the next part is, once the service is created, you can go to that service. Let's say this is the service that I have created. Let me go to the AI Foundry portal. From here, we are going to grab the model information and the endpoint. Okay, so under the model sections, if you go to the models and endpoints, you will be able to deploy the model. So you can see this is the GPT-4o model that I have deployed, mini model. So for deploying, you can just select deploy base model. You can select the respective model that you want to use. So there are a couple of models that are available on Microsoft. Okay, you can see this is the model catalog from where you can select. We have selected the GPT-4o, and let's say GPT-4o, you need to select this. In the customization, you can go ahead and change the input rate, tokens input rate, and all that detail, and you can deploy. So I have already deployed this model. Now, in order to grab the endpoint detail, you can go to overview, and from here, click on Azure OpenAI. This is the endpoint that we have used. We are using this Azure OpenAI service. We are not using Azure Foundry service as such, because again, the Azure Foundry is one shop platform available where all the Azure AI services are available now. So you can consume Azure OpenAI service from this particular endpoint itself. So that is what we have given as a Azure endpoint and the Azure OpenAI Azure OpenAI deployment name. And in order to log into this particular portal, we'll be using AC login. So that again, it's a standard industry practice because we are not using keys in order to connect to these AI services, which is not safe. And in the organization, we don't use key-based authentication. Instead, we use role-based access control. So that is what we'll be using. Now we have added the environment configurations and the requirements, so we are good. Now we can go ahead and start writing our first file, which is a machine learning related model. So, but okay, before that, the environment is created. So let's go ahead and activate the environment. So I'm a Windows user. So again, the activation is a bit different in Windows versus Mac. You will easily find that. So, okay, we have activated the environment. Now the next step is, let's go ahead and install the dependencies. So pip install -r requirements.txt. So it will go ahead and install the dependencies. So meanwhile, and one thing I forgot, that I'm using Python 3.13. You can also go ahead and use 3.13 or latest Python environment. That is completely fine. Okay, so first file that we'll be generating is, let's say, the model training file. So let's use So we'll be using a IPYNB notebook so that we can go ahead and write a code line by line for this one. But at the end, once the machine learning models are trained, once the machine learning models are ready, we'll go ahead and use the .py files as well. We'll build actual project like structure. So meanwhile, the installations are happening. Let's go ahead and select the kernel. So we'll be using Python environments 3.13. That is what the one we have created, .venv. So let's do that. And under the code, let's say whether it is working. Okay, so it will ask us to install the IPY kernel. So let's go ahead and install that quickly. So basically it will install the Jupyter related information required in order to use this project. And let me go ahead and change the theme so that it looks good. Let's use white theme. Okay. Now this makes more sense. Okay. So the first part is done. It is still installing. Let's wait for the installation. Okay, so it is working. So let's go ahead and import the necessary dependencies. So this complete project, we have categorized it into three phases. Phase one is the machine learning model training. Phase two is building agentic AI application. And phase three is nothing but building the user interface. So for now, we are starting with phase one. So let's go ahead and import the necessary dependencies that are required. So as you can see, we are starting the phase one, and these are the dependencies that we'll be importing, like the normal dependencies and the profit model and the scalar matrices in order to identify the accuracy of the model. Then we are creating two directories. So first one is the data directory where we'll be uploading this particular data, and the artifact directory in order to save the machine learning model, train model. Let's go ahead and create the data directory first where we will go ahead and add the data. So let me go ahead and add the smart home energy consumption CSV, and then we can take a look how exactly it looks like. Okay, so I have added this file. So let me open and show you the information beneath this particular file. Okay, so you can see we have home ID. That is fine. And then I have picked this data from the Kaggle. I'll drop that link in the comment section as well. Then we have home appliances, fridge, oven, dishwasher, all that appliances that we have. Then the energy consumption. So if you are using fridge within this particular time, it was used, and on this particular date it was used. This was the energy consumption. Then we have outdoor temperature. What was the temperature at that time? What was the season? Household size? Now this information is available in on the Kaggle. So that's the data set that I have used. So you can see there are a lot of information that is available across each appliances. And let me go ahead and show you that data set. Okay, so as you can see, this is the data set that we are using, right? Home ID, appliance, energy consumption, time, date, and the outdoor temperature, household size, and the season. So I'll drop this link in the comment section from where you can go ahead and download this data set. Now, this information we are using in order to build the machine learning model, train a machine learning model. So whenever we are training this machine learning model, the purpose of this data set is that to understand if we are using, let's say, air conditioning, let's say for let's say 5 hours, and let's say the household size is 3, then what was my energy consumption, or what was the standard energy consumption. So in order to identify the predicted energy consumption, as we discussed in this particular phase, after passing this information, what's going to be my next day predicted energy consumption. So that is what we are generating as part of this. So we have created this. Let's go ahead and execute this. Now the next step is to go ahead and load the data set. So let me add the code for that. We are loading the data set, and again, we are making sure that we have these expected columns available in the data set. Then we are reading the PDF. We are identifying if any columns are missing. If yes, we are raising the exception. So that then next one is the standardized column names. We are just renaming the columns. Okay, then we are changing the data types, and also you can see whenever we are changing, let's say date, we are converting to date, time to time. Then you can see this particular one, errors equal to coerce. So this is basically what it does is, let's say whenever we are converting this date to date, and let's say if the value is not a date value, it is something else. In that case, this particular part will fill that value with null. It will make sure that your code will not fail if you are passing this. If there is any, let's say, string available instead of date, then if you don't pass this, your code will fail. That okay, string is not allowed. or string is not a data type. So this will make sure that it will replace that with null. So that's what we are doing, and then after that we are dropping the null. So if there are any bad values, that's what we are removing. So let's go ahead and execute this, and let me show you the data frame. Okay, so this is the final data frame now. Appliances, the energy consumption, time, and the date information, and the temperature, everything. The next step is to combine the timestamp and perform a basic cleaning. So basically we'll be combining this date and the timestamp value. Okay. And again, this is the information that we ideally obtain it from the IoT devices. Like, okay, this was the appliance of fridge that on this particular date at this particular time, this was the energy consumption that it consumed. Now, if you filter the data based on date, you will find that for same home ID on the same day, it has captured basically the energy consumption at multiple time interval. So we will be aggregating that information to identify the daily usage, and we'll be taking an average of that. So if I'm selecting home ID, let's say 94. Okay, so if you see for 94 home ID, and let me also select the appliance. Okay, so if you see for fridge, so on the same day, if you see, there are two records. One record captured at 12:04, another record captured at 21:02. So that's how it is capturing this particular information is available. So in a single day, there can be multiple instances where we have recorded this data. So, okay. Now, what we are doing is we are creating a timestamp column. Then after that, we are checking a sanity bounds, like we are keeping the one with greater than 0 kilowatt hour units and less than 50. Then again, we are checking the household size. It should be between 1 and 20. Okay, then we are doing the season imputing. So basically, we are converting the seasons into the months. So basically, if you see winter, so winter is nothing but month 1, 2, and the 12th month. So basically the December, January, and February, these are the winter months. Then if you see March, April, May, these are the spring, right? June, July, and August are the summer, and then the remaining are the fall. So that's how we have categorized season into months. So we have obtained the monthly information from that. Let's go ahead and check that. Let me close the terminal. Okay. If you see, now we have obtained the month information. Now the next step, we are going to perform a daily aggregation so that we can achieve the aggregation data. So if you see in the aggregation, what we have done is we have grouped it by home ID, appliance, and date. So for each home, for under each appliance, and for each date, we are calculating the average. So in this case, the average will come. So if you see here, the average will come as, let's say it was 0.20 and 0.24. So the average will come close to 0.22. So that's going to be my energy consumption for fridge. So let's go ahead and execute this. So we have obtained the aggregation. Now, if you want to see that, if you see the aggregated data now, so we will have one record. So if you see for home appliances at one date, this is my aggregation. This is my daily kilowatt hour. This is my average temperature, all that information for each appliances. Now, next step is we'll go ahead and generate the cross home appliance daily usage. So if you see, we are aggregating cross homes to learn generalized appliance behavior. So as you can see, we have grouped it by on appliance and date, and then we are checking the daily units, the average temperature, household size, and is weekend or not. So this information will be utilized for the model because we want to aggregate it based on the homes. Now, this we are generating a generalized or training a generalized model. We don't want to train it based on the house IDs, because in the personalized recommendations, house ID doesn't matter, right? I'm using it for my house number or ID doesn't matter to it. So we are building a generalized model which will predict based on the instances happen or captured on real time what is my consumptions for these air conditioning and washing machine. Again, there is scope for improvement. You can use the real time example or real time data for your home appliances. If you have IoT devices installed, you can grab the information, real time information, and train the model on top of that. But to be on simple side, let's go ahead and use this data itself because we don't have that. And So that's what we have aggregated this information, and now the appliances daily is available. We have dropped the home IDs, as you can see. So for appliances, this is the date, this is the Y, meaning the output, energy, average temperature, household size, and is weekend or not. Now what we have done is we have created the dataset in the format so that we can use it for training the machine learning model. So where appliances, date, average temperature, household, and weekend are our X, and this is our Y, that is our output column. So these are the remaining input column and the output column. So how the model will learn the pattern for this particular appliance, and with this particular average temperature and household size, this is my energy consumption. So based on that, it will go ahead and generate the recommendations for us later on. Now, once this is done, the next step is to split the data. So we are doing the splitting based on the time that we have available. Again, the time frame that we have is from the date 2023, 2024. Again, we don't have the latest data, but we'll be able to manage it. We are just simulating the project. Once we have the actual data, you can definitely replace it. And for the time split, what we are doing is first 80% data we are keeping it. So the 80% based on this time frame. So let's say if you have the data from first January 2023 to 1st January 2024. So 80% of that, meaning somewhere close to September, October, it will keep the data for training, and the data after, let's say, mid of September, it will keep it for the testing. So that's how we have done the time split. You can see the data set less than 2010-2023, meaning less than 20 October, it has kept it for the training, and remaining it has kept for the validation. So that's the split that I have obtained. Now the next step is to define the metrics. Again, we'll be using a yes map. Yes map is nothing but symmetric mean average percentage error. So that is what we are finding out. So if you see, we are creating a denominator y true minus y predicted divided by 2, and the difference of y true minus y prediction, and that's how we are calculating this particular value and multiplying it by 100. So this is in order to find out the accuracy, how accurate our model is. We have defined this metrics. Now next step is to define the profit factory. We'll be using a Facebook profit. So if you are not sure about the Facebook profit, again, it is a library that we use to perform a time series operations or to build a time series forecasting model. As we have the energy consumption across date, that's where we have used profit model. You can use another models as well. I have tried XGBoost, light gradient boosting. I have tried. Also, I have tried with the deep learning model, but I could not achieve much good results, and that's where I've used the forecasting model. I have tried LSTM as well. So with profit, I achieved good accuracy, and that's where we are keeping profit only. You can go ahead and use the model of your choice. That's completely fine. So for this, again, for profit model, we have past daily seasonality. Definitely, it is very much important. You need to include the seasonality factor, weekly seasonality, yearly, and seasonality mode. So we have given this particular seasonality because we are dealing with the temperature related information, weather related information, so it does matter, and that is where it is giving the good accuracy. Okay, so that's how we have built the profit model. Let's go ahead and execute this. So we have written it as a separate function. Now next part is to define the trend test split. Now in this, what exactly we are going to do is we are going to build a separate individual model for each appliance. So whatever appliances that we have, for air conditioning, we will identify the information and will perform a trend test split for air conditioning, and will train a separate model and will save that into the artifact. For washing machine, we'll train a separate model. Similarly, for other appliances, we'll keep a separate model or individual model. Now, why it is important? Because if you see, for air conditioning, the energy consumption is completely different. For washing machine, the energy consumption is different. You can see there is a vast difference between those. And that's where we are keeping a separate model based on the category. You can train a generalized model as well. That is completely your choice. In order to achieve the accuracy, I have categorized it into separate model so that whenever user is selecting the category on user interface, we'll call that respective artifact model. Okay, so that is what we have achieved here. So if you see, we are iterating it based on the appliances. So we are picking the unique appliances, and we are taking out a separate database for a data frame for each appliance. And in that data frame, we are calculating a training and validation data frame. And once the data set is ready, training and testing, then we are going ahead and creating a object for profit model. You can see with the help of make profit, we are creating the object and then we are fitting the machine learning model. So m.fit, we are passing the train df. Once it is done, then we are calculating the validation. So we are performing a prediction where we are calculating y true and y prediction, and then we are calculating the error. So first of all, we are calculating the mean absolute error, then root mean square error, and then we are calculating the SMAP. That's what we have discussed earlier, the SMAP function that we have defined. And then we are printing these particular results, and we are appending it into the scores so that we can print the scores at the end. And once that is done, you can see we are saving the model at the artifact directory where we are giving name profit underscore the application name. Let's say if it is air conditioning, we'll give name as air conditioning, and we are saving it as a pickle model. So we are dumping those models, and then these models are dumped into this particular artifact directory. And at the end, we are printing these particular matrices. Next, we are going ahead and clean the registry. So basically, it will just go ahead and normalize the path before saving. So this is in order to replace the artifact path. So how exactly it will be, let me go ahead and execute this. Okay, so you can see it has started the model training and it has completed the model training for all the appliances that we have in the dataset. So you can see it has created artifacts folder, and under artifact you can see we have Prophet air conditioning, Prophet computer, Prophet dishwasher, fridge, heater, light, microwave, oven, registry, TV, washing machine. So for each individual one, it has created this particular model, and then in the Prophet registry that we have created, it is capturing all the paths. If you see air conditioning, this is my model path, and these are the regressors that we have used. So basically, regressor meaning these are the continuous columns that we have used. Rest are the categorical column, that information split date it is giving. Similarly for computer, dishwasher. Now why this particular file is required? Because whenever we are loading the model, we need this particular information so that whenever we are performing a testing operation or prediction operation on new data, this will help which model to use and what are the data types that we need to make sure that we need to convert or typecast before passing that input to the prediction model. So that is what we are generating. If you see, that is what we are generating in the clean registry. So in the registry, we are renaming the paths. We are again all these models, again you can see we have lowercase those models, and all that information, that is what we have stored it into the profit registry. Okay, the next step is to infer the model. So in order to infer the model, let me go ahead and add the code. So in order to perform the inference, so this is step number 10. Okay, so for inferencing, as you can see, we have written a predict next day function. As we have discussed here, we are passing a particular inputs to the ML model, and it is generating the next day prediction of energy utilization. So that is what we are passing appliance, the next date, then average temperature, household size, and whether it is a weekend or not. And if you pass this information, it will go ahead and generate the energy consumption. So for that, we are loading the registry, the model registry that we have generated. Based on the appliance, we are passing the, we are extracting the model path out of that particular registry. Then if the model is not available, that's fine. Then we are just checking whether the path is exist or not. Then we are loading the profit model with the help of pickle. Again, with pickle.load, whatever model that we have said, let's say the appliance is air conditioning. So for air conditioning, it will go ahead and use this particular model path, and it will load profit air conditioning model. That is what we have written, simple thing. And again, we are building this particular data frame. So whatever information that we are passing, it will be converted it into the data frame, and then we'll perform a predict function. The profit model dot predict the future data, and it will return this particular, for this particular appliances, this is the date, this is my y hat, that is the prediction, y hat lower and y hat upper. Basically it will give the energy range, that okay, this is the predicted range, but this is the lower limit and the upper limit. So let's execute that, and let's quickly test it with one of the example. So with this example, as you can see, we are calling this particular function that we have written. Appliance, we have passed it as washing machine. The timestamp, we are passing today's date plus 1. Then average temperature we have passed, let's say tomorrow it's going to be 10. The household size is 3, each weekend is 1. Now this temperature, again, it will be predicted with the help of the forecast API that we'll be using. So that's how we are passing, and let's go ahead and execute that. So if you see, so tomorrow's date is 13th, and this is going to be my energy consumption for washing machine, close to 1.05 kilowatt hour. So 1.05 unit. And again, these are the two range that it has generated, lower range and upper range. So yeah, that's how we have built the machine learning model. Now we'll pass this particular information, and in that information, it will use household size, air conditioning. We will pass this particular air conditioning and the date information, and it will go ahead and generate this particular predicted energy for us. And once this energy is generated, it will be passed to the agent. Now the first part is done, where we have built this particular section. We have used the open source dataset that is available. We have built the Facebook profit model. Then we have identified the next day energy prediction, and that we are passing to the Microsoft agent. So till this part, it is done. So let's go ahead and build the second part, that is the weather forecast API, the yesterday's energy consumption, and once it is ready, we will bind them into the agent. So the phase 1 is completed. Now let's start working on phase 2 to build these particular two tools and the first agent. Now, in order for us to use this particular prediction, first of all, we'll have to add this prediction function into a separate file. So let's go ahead and create a prediction.py. And under that, I'm adding the exact function that we have written. So if you see, we have imported these dependencies, then define the artifact path, and the same function you can see, predict next day, same function that we have written, and we have added one simple example as well to test it. So let's go ahead and test it one more time here. And this we are doing in order to make sure that, because we'll be building an API. So for each of these particular service that we are creating, or the tools that we are creating, it will be as an API, and that API will go ahead and extract the information and will register that API to the agent. So let me open the terminal and let's execute Python prediction.py. So it should go ahead and generate the recommendation. So you can see we have tested it with this particular example, where we have passed air conditioning and these information, and it has generated the predicted energy consumption can be 3.43 kilowatt hour. So that's what we have tested. So the first function that we have written. Okay, so that's where the first phase is completed. Now next step is, let's go ahead and start building the agent.py. So let's create agent.py. Now under the agent.py, we will go ahead and write all the things that we have discussed. So first we'll build this weather forecast, yesterday's consumptions, and then we'll build this particular agent 1 and agent 2 as well. So that's our phase 2. First of all, let me go ahead and import the necessary dependencies. So as you can see, this is our phase 2, where we are building this particular file agent.py. And for this, as you can see, we are using Microsoft Agent Framework. So in this file, we'll be building two agents. First one is the user collector agent, which will collect the last usage from the CSV and the tomorrow's forecast, along with the machine learning for prediction. And the second agent is the recommendation agent, which will analyze actual versus the forecasted usage and generate the final recommendation. So that is what it will do. So these are the dependencies that we have imported. So you can see Pydentic in order to define the standard format. Then agent framework, we are importing AI function. Then from agent, again from agent framework, we are importing the Azure OpenAI chat client, with which we can communicate with the agent that we are building. And again, Azure identity in order to log into the application. Now, and again from prediction, we have imported this prediction next day kilowatt hour. So from prediction, this is the function that we are importing. Okay, so that's the basic thing. First of all, let's go ahead and log into our system. So for that, use AZ login. So in order to log into the Azure account, use AZ login as a command. For that, you need to install the Azure CLI. First of all, let me show you that. So you can see once I enter AZ login, it is asking me to log into the application. So let me select the email ID. Okay, so based on the authentication system that you have integrated for your Azure subscription, for your Azure account, it will go ahead and you'll have to complete that step. So, okay, you can see it is saying that, okay, this is the Azure subscription that is available. So let's go ahead and select this by hitting enter. Okay, so we are able to log into the Azure portal now, so that we can consume the large language model that we have defined with the help of these endpoints that we have added in the environment config. Now, let me go ahead and define the path. So we'll be using this particular CSV, appliance usage. I'll show you that CSV, and the currency is INR. So let me go ahead and copy the CSV first. Okay, so under the data, I have added another CSV, appliance usage CSV, and what exactly it is, let me show you that. Okay, so if you see, we have a date. For that particular date, what was the appliance that we have used, start time, end time for that particular appliance, what was the mode, what was the energy that was consumed, the average temperature, and the weather condition. This is the actual data that you can obtain with the help of your IoT device. Now we have created this data so that we can use this data. Let's say today is 4th, or let's say today is 8th. So on 8th, I have used this particular air conditioning around this particular period. This was my air conditioning mode. This was the actual energy that it consumed. This was the temperature outside and the weather condition. Now, this was my yesterday's weather. With the help of weather forecasting, we'll identify tomorrow's weather. We'll compare both the weather condition, and that is what our recommendation agent will generate the recommendation by comparing both. So let's say today it is 32. Tomorrow it might be, let's say, 30 degrees Celsius based on the forecasting. So based on that, it will recommend the good condition or good setup for air conditioning. Let's say tomorrow, if it is going to be 25 degrees Celsius, for example, then it will say that, okay, you no need to use the air conditioning in this particular period. You can reduce the usage of air conditioning. That is what it will generate the real-time recommendation. So for that purpose, we have utilized this usage CSV. And again, this CSV, whatever is the today's forecasted value or whatever is the today's setup, it will be captured as and will be used for tomorrow's forecasting. So that's how it will go on. Now next step is we will go ahead and use the weather forecast API so that we can identify the tomorrow's weather. So this part we have built now. Yesterday's CSV we have not integrated it as a part of tools to the agent, but we know what exactly is there. Now the leftover part is this particular tomorrow's weather forecast. For our weather forecast API, we need a latitude and longitude information. And for that, we need to use this particular function, first of all, to identify whenever user is passing the city, it is getting the geocode location. So for that city, it is identifying what is the latitude and longitude. So with the help of this particular open source API that is available, once you pass city, it will go ahead and return these particular information. So let's go ahead and test that whether it is working. So to test it, let me go ahead and call this particular function. And we need to pass city. Let's say I'm passing Pune, and we need to give max results. Let's give one only. Again, it's a default parameter. Use Python agent.py. Let's see whether it is returning this particular condition. Okay, sorry, I forgot to print the results. Let me go ahead and hit it. Let me go ahead and rerun this. Okay, you can see for Pune, it has extracted the latitude, longitude, and this information will be utilized to pass it to the weather forecast API. So let me go ahead and add the weather forecast function. Okay. So we have written the function to get tomorrow's weather, which accepts latitude, longitude, and the time zone. That is what it is generating. So if you see, again, it is using this open source API, Open Meteor. And for that, if you pass these particular parameters, it is generating the weather forecast. So if you see, generating temperature max, temperature minimum, weather code, that information it is generating. So if you see at the end, it is returning date. So based on tomorrow's date, this is going to be the high temperature, low temperature, and the weather condition. So let's go ahead and test this as well. So for this particular weather condition, in order to test that, what we need to give is the result obtained from this particular GeoCity. So let's go ahead and call get weather. We'll store it as output, let's say. And for this, we need to pass first parameter as latitude, longitude, and time zone. Latitude, we can pass it as lat. From results, we are picking lat. So result is a list of dictionary, right? So out of this list, first of all, we need to get the list of 0. So out of result, we have obtained it as a dictionary. Out of the dictionary, we are finding out the latitude. Similarly, result of longitude. And time zone, let's pass the time zone as the Asia one that we are selecting. So from here, let's copy this particular time zone and let's pass it here. And let's see whether it is generating the output. Now let's go ahead and print the output. Let's go ahead and run the file. Okay, so if you see, after passing this particular information, it has picked it as for this particular date, tomorrow's date. This is the high temperature. low temperature, and condition it as partly cloudy. So that's the information that it is giving. So cool, meaning our weather forecast API is also working. Now we need to register this particular API as a function for our agent. And in order to register that, we need to use this particular AI function. So this will be a decorator with the help of which we can go ahead and add or convert our normal function into the tools for a agent. Before that, I think we have missed one step. We also need to create a function in order to get the CSV as well. So let's add that. Whatever yesterday's usage rate that we have utilized or that we'll be utilizing. So you can see we are reading that particular CSV, and out of that CSV, we are just getting the records for the latest date. Out of that, we are selecting latest date, and out of that latest date, you can see we are converting date to date time format, and out of that, then we are converting the records into the proper format, and we are returning date and the usage, and that we are storing it as a dictionary. So that is what it is returning. So out of this particular get last usage from CSV, we are converting these records into the dictionary. So whatever records that we have in this particular file, for the max date, let's say for this one, it will find out air conditioning and all these reports, all this information in the dict file. So let's go ahead and quickly test this as well. So let me add this in the main function to test. Let me hide this. Again, result equals to, let's say, this one, and what we need to pass is the CSV path. So CSV path we already know, this is the CSV path. So let's go ahead and pass that, and let's run the file. Oops, I forgot to print it. Okay, so if you see for this particular date, it has identified the usage. So for usage, you can see for this date, appliance was air conditioning. For air conditioning, this is the start time, end time, this is the mode of cooling, this is the energy consumption. So that's how it is capturing information for, let's say, first for air conditioning, then for dishwasher, and for all the appliances, like microwave, computer, for all the appliances. So that is what we are generating. We are just converting it into the dictionary format. So that's the function of this one. And we'll be utilizing this in order to get the, or basically in order to convert this into the function tools, so that we can pass that function tool for our agent, and agent will call it dynamically as and when required. So just to be to make the format clear, let me remove it from here and add it on top of this, because these two will be converting it into the function. Now, in order to convert that into the agent function or agent tool, we just need to use the decorator. Okay. So the first decorator that we'll be using here, you can see AI function we have used, and with the help of @ we are marking it as decorator. Name we have given as get last usage from CSV, and description, what it does is it loads the appliance usage for the most recent data in the, or most recent date in the CSV. So the first agent, task of first agent, as we have seen earlier, is to identify this particular information or collect the information, and the task of second agent is to perform the optimization. So for building this particular first agent, we need to define this, or we need to give it as a function or tool. So if you see here, we are binding it as a tool. So that is what we have done this stage. We have bind this particular function CSV to this particular tool. Now we will bind this weather forecast to this tool, and then we will bind this prediction as well as a tool. Okay. So for weather forecast, again, with the help of this, we are passing the name as get tomorrow's weather, and the description get tomorrow's weather high low condition using OpenMeteo API. Now this description will help our agent to identify what are the functions available with the agent and what are their description, what tasks they can perform, so that based on the user query, agent can automatically select this function as and when required or execute this function. Now the third function that is pending is the forecasting. So let's go ahead and use that function as well. Okay, so if you see, we have written this particular forecast next day kilowatt hour function. So for which we are already written this particular prediction function in the prediction.py. That is what we are calling, and we are passing these information: appliances, date, average temperature, household size, and each weekend. All that information we are passing. Now, what will happen is that our agent will utilize the weather forecast API. It will identify the average temperature. Then household size, it will pick it from the user question. Whether it is weekend or not, it will again pick it based on the date that we are passing. The appliance, it will pick it from the user, that the value that the user will give. Now, based on this date and the forecasted values, it will pass it to the predict machine learning model that we have built, and then it will generate the recommendation of it will identify the predicted usage. So let's go ahead and convert this into function as well. So with the help of this simple decorator, we have converted this into a tool. So forecast next day kilowatt, description predicts appliance level in kilowatt hour usage directly using the machine learning model. So now our agent that we will be building will know that, okay, these are the three functions that we have registered to the agent, and it knows that when to call these functions. This part we have already covered now. First, second, and third, and we have converted them into the tools. We just need to bind it into the agent. So let's go ahead and create the agent now. So now we are going ahead and creating the first agent. Okay, so let's create the agent. First one is the create usage collector agent. And again, we are writing it as a function. We have given instruction, you are a usage collector agent which loads the appliance data, get tomorrow's weather forecast, and for each appliance, gather the next day kilowatt forecast. So that's how, and return the data in this particular format, last usage, again, the last usage, weather, and forecast. So the thing that we have discussed here, this particular agent will return the information in this particular format: date, yesterday's usage, weather, ML forecast. So if you see last usage, weather, that is what it will return. Last usage, weather, then forecast, ML forecast, that is what it will go ahead and return the information in this particular JSON object. That is what we have defining the protocol, that okay, go ahead and return the JSON only. And in order to create the agent, we are using Azure OpenAI chat client. That is what we have defined. So if you see, we have imported Azure OpenAI chat client. Then in order to create the agent, it is very simple. We have created the client, and for the client, we are using Azure credential. So if you see Azure CLI credential, we have used easy login in order to log into the portal. And again, I think I missed that part. So you can go ahead and install the Azure CLI. You just search Azure CLI, and based on your operating system, go ahead and install the Azure CLI. So you can select the Microsoft installer or PowerShell or package manager, and zip file, and you can download and install that. It is simple, just like installing the game. You need to hit next, 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 and the installation will be done. And once it is there, you can go ahead and use the easy login command here. Now, if the easy login is still failing, you need to set up the environment path. So just copy the path wherever you have installed, and you need to add that as an environment variable. So if you're not aware about that, just Google it. It is very simple. You just need to add it as a path. Now, so that is what this particular credentials will do. It will use my role in order to connect to the subscription to this particular AI Foundry service, and it will grab the GPT-4o model that we have deployed. So we have created the client, then client.create agent. It is that simple, creating the agent in MAF, Microsoft Agent Framework. We are passing the instructions and tools. So all the tools that we have created, get last usage from CSV, get tomorrow's weather, forecast next day, these three functions that we have defined. Now these functions are marked as a tool with the help of this particular decorator. Decorator is decorating those functions, changing the behavior of those functions to return or to accept it in the format of Microsoft Agent tools. So that is what we have converted these functions. Now this agent is smart enough to know that this create usage collector agent, smart enough to know if user is asking question, what instructions needs to follow and what are the tools capability that it have to perform the operation. Okay, done. So we are done with our first agent. So in the phase 2, we are done with this particular part. We have built this complete agent. Now in the phase 2, this second agent is pending. Let's go ahead and build this particular agent as well. Okay, so for second agent, again, let's go ahead and define the second agent. So again, we are creating new function, create recommendation agent. Instruction we have passed. You are a recommendation agent, takes last versus tomorrow's forecast from usage collector agent. This is where we are deciding that, okay, you need to call the usage collector agent first. Suggest a optimized setting for all appliances. Be very mindful while generating. Don't be blunt. We have added all that instruction. And then we have defined the protocol for generating. So you need to return in this particular format only. You need to return the summary, actions, appliances. That is what we have defined on our flow diagram as well. So if you see, it is generating the final recommendation in this particular format. Summary, actions, and the for each appliances, it is generating the recommendation. So that is what we have defined as a protocol for this agent to generate this. And again, with the simple Azure OpenAI chat client, by passing the Azure credential, we are creating the agent by just passing the instruction. For second agent, we don't have any tooling. So the task of second agent is just to grab the detail generated by user collector agent, analyze it, and generate the response in this particular format. So here you can go ahead and add a lot of your instructions as and when you want to add. So in order to improve the results. Now, this part is also done. We have passed the yesterday's usage, tomorrow's weather forecast, and EML predicted. We are going to pass in this particular format for our this agent. Now, as the individual agents are ready, let's see how exactly we can build the communication between these two. Now, for agent execution, let me go ahead and add the code. So we have just created the individual agent. Now it's time to execute the agent. Now for this one, we have defined a asynchronous call. We are created a run agent function. And in that run agent function, you can see we are calling collector agent and the home agent. And we are passing a profile, home profile. We'll see what exactly is this home profile. So you can see we have created the object for both the agent, and then we are defining all this information. So again, first of all, we are just getting the geocode. So if you see, whenever user is passing the profile as city, so from the profile, we are picking the city. What exactly is the profile? So whatever information that we are passing here, this is our profile. So in this profile, whenever user is selecting city, now in the profile, if you see, here exactly what we have passed is the city. We have not passed the latitude and longitude, but the weather forecast API accepts longitude, latitude, as we have seen here, right? So converting that city to this from extracting the latitude and longitude from the city, that is what we are performing here. So that will be passed as profile, meaning we'll pass household size, city, all that information. So first of all, we'll get city from the profile, and for that we will apply this particular geocode city that we have written individual function. And from that we will get the latitude and longitude information that we are appending it into the profile. Then we are getting the latest CSV, so raw prompt from the CSV, from which we are getting the CSV path. The profile we have tomorrow's, then we have tomorrow's information, whether it is week or weekend or not. So we are preparing the initial prompt. Then in the executor, we are creating the executor, the collector agent object that we have created from the create collector usage. Then we are executing the collector agent. So collector agent dot run, the collector agent object that we have created from this particular create usage collector agent. So to run the agent, it is very simple. We need to agent dot run, and we are passing the information as a raw prompt. So in the raw prompt, we have passed CSV path, then the profile the user has entered, then the tomorrow's forecast, weather forecast, and whether it is a weekend or not. That information we are passing. Now, if you see, is weekend or not, we are getting it based on the weekday. So we have used this particular date time. So based on date time, we know that what is the today's date. So for today, it will go ahead and identify whether it is a weekend or not. And basically, we are adding one day date time for today plus one day, so that we are performing this operation for next day, right? So that's how it is checking whether it is weekend or not. And these input parameter that it is passing to the agent, so that agent accepts this raw prompt. Based on that, agent knows that, okay, I have CSV, I will go ahead and read the CSV. What I need to do with the CSV? I need to go ahead and read the CSV and generate the report in this particular format or execute that particular CSV. So this is the function that I have. I will go ahead and call this particular function. That is what we have registered as well. So as you can see here, we have registered it for the create usage collector agent. So that is what it will do. It will take this CSV path, execute that, identify the attributes. Profile, it will pick it from the user. It will call the tomorrow's weather forecast, and also it will check whether it is a weekend or not. That information we are giving it to the agent, as you can see. Okay, so once the raw prompt is passed, it will go ahead and execute this particular agent, and we have used save JSON extract just in order to generate the response in this particular format. Then from collector result, we are converting it into the text and then into the JSON, and that's how the collector data is obtained. Okay, so for our prediction one, what we passed is the appliances, next date, average temperature, household size, each weekend. That information we have already passed for the first agent. So if you see from the CSV path, it will get the date information. It will get the we have passed the tomorrow's date, so it knows the date, whether it is weekend or not, that we have passed. Then we have passed the profile. In the profile, we have all the information. What is the appliance category? What is going to be my min max temperature? That information it will pass based on the weather forecast. Now this knows that to call my this particular function forecast next day, I need a minimum and maximum temperature or the average temperature. So it will calculate the average temperature and pass it to this particular function. So in order to call this, as we know that we need to pass the appliance, which it will pick it from the user, or we know that we have selected the appliance. Date, it will pick it from the date that we have given. Average temperature, it will pick it from the weather forecast. Household size we are passing is weekend or not, that information it is we have already given. So it knows all the information required to call all the three tools, and that is what this much information is sufficient for calling all the three tools. So it will go ahead and do that. The next agent we are executing is the recommender agent. So the recommender agent that we have already defined here by creating this particular object, and in that dot run we are analyzing the recommendations where we are passing this particular input in the format of JSON obtained from the first agent. So first agent output data, we are passing it to the second agent, and this is the protocol that we have built. It is converting it into the JSON, and that is what we are giving it to the recommender agent, and then recommender agent again it is returning it in the JSON format as we discussed here. So this format we have given it to the agent 1, and agent 1 is now returning this particular format. So that is what we have built here. And at the last, we will just go ahead and run this particular agent function. So the function that we have defined, this run agent, we will go ahead and run the agent, and we'll use a sync IO call in order to run the agents parallelly. So we have passed the profile information that we need to pass. So first of all, what exactly is this home profile? Let's go ahead and define the home profile. So if you remember, we have imported this data class from the data class library, which will help us define the standard data class format. So okay, I'm adding this data model. So for home profile, it is a class of decorator data class where it is going to make sure that the data class to represent a household energy user profile. Meaning, whenever we are passing this home profile, it will pass the home profile in this particular format. Household size in int, appliances as a list, rate peak in this particular float values, tariff, and the time zone, all that information it has passed. So this is what we are passing it as a home profile. Now let's go ahead and test the application by calling the agent that we have built. So under the main function, let me go ahead and add this. Okay, so profile, we have defined home profile where we are passing household size as 4, appliances, these are the appliances that we have selected, and other parameters that we have already passed it as default. Let's say rate, the tariff, longitude, latitude, all information we have already hard coded. We have already given as a default value. So we need to pass that. Mandatory details that we need to pass are the integer and string. So that is what we have given and done. So with the help of run agent that we have defined, which is a synchronous call, we'll go ahead and pass the profile. That is what is expected, and it will generate the response. So let's go ahead and run this particular file, python agent.py. It should generate the recommendation in the format that we have defined. Okay, ISO date is not defined. Let me go ahead and define that. Okay, sorry, two functions I missed to add, two helper functions. So let's go ahead and add that. Okay, so in the helper function, we have used ISO format where we need to pass the date that we are passing and it will convert that into the uh, ISO format, year, month, and date. Then we have a safe JSON extract. That's what we have talked about earlier. So which is just in order to extract a valid JSON out of the response text. That is what we have given. So let's go ahead and see now. If there are any issues, we'll fix it. Let's run python agent.py. Now it is going ahead and hitting to the agent that we have created, and agents will access the GPT-4o model that we have defined, and it will start generating the response. First, it will call the first agent, which will generate the response. It will pass it to the second agent. Okay, you can see for collector agent, it has generated this particular response. For each appliance, you can see it has generated the response in this particular format as we discussed here. This is a format that it is generating: last usage rate, and for this particular date, this is the last date that is available when we ran these particular appliances, or we have the captured usage rate information. So air conditioning, this was the start time, end time. It is collecting all the information. Then for predicted kilowatt hour, you can see it has called the, first it has called the last usage CSV. Then it has called the weather condition. You can see it is predicting it as all the weather condition information. Then you can see it is calling the predicted kilowatt hour as well. So for each appliance, it is calling the machine learning model and identifying what is the prediction that is happening. So from the artifact, these artifacts, it is calling these particular models individual as per the appliance, and it is generating the prediction as well. And all that information, then it has passed it to the second agent. So second agent is generating this response that, okay, summary, tomorrow's weather will be partly cloudy with a high of 27.8 degrees Celsius. All that information, and then it is generating the recommendation for air conditioning. Set it to 26 and use only between this particular hour. Estimated cost saving, washing machine. So this information that we are seeing on the user interface, the appliance recommendations, all that information that is captured. So that's how successfully we have completed the phase 2 of the application. So as you can see, as we discussed, this is the phase 2 that we have completed by building this agentic AI system. So now our application is ready to move. Now we are ready to move into the phase 3 of the application. So first, we have built as a machine learning model, which is identifying the predicted energy, and we have given it as a capture it as a separate phase, because again, it is a big stuff to train a machine learning model and come up with the experimentations and final result. Then second, we have built this particular agentic framework where we have integrated all the custom APIs or tools, functions that we have written. We have registered them as a tools for the Microsoft Agent 1, the energy usage analysis agent. Second agent we have built is the energy optimizer agent, and we have built this particular second agent as well. And it is, we have exactly seen how exactly it is generating the usage rate, the recommendations for generated by agent 1, we are passing it to the agent 2, and agent 2 is generating the final recommendation in this particular format. Now the phase 3 that is pending is passing this information to the user interface and building the user interface. Now, before that, now in order to consume this information for the user interface, we'll have to test the APIs. So for that, we will go ahead and build the fast API application where we will test whether these APIs are working or not. Okay, so if you are still following the project, then I'll really appreciate your efforts, because staying this long for one particular tutorial, it's not easy. So appreciate for your efforts. So I took a small break. So if you have not taken any break, please go ahead and take a small break and come back quickly. Okay, so now as our agent.py is ready, and we have seen that we are able to generate these particular responses, now it's time to build the API. Now, in order to build the user interface, we need to make sure that we are articulating all those details in the API format so that we can share these API details with the UI developers, and they can integrate and build a beautiful UI out of that. For this project, we will be building a simple UI with the help of Streamlit application, but for that we will need to build an API endpoint. So let's start working on building the API endpoint. Okay, so to start on that, let's go ahead and create one file, app.py, where we will write all our API information. And let me go ahead and import the necessary dependencies that we'll be adding. So as you can see, this is app.py where we will be building two endpoints, optimize the energy, which is going to be the agentic energy saving optimization, and email plan, which is going to format plan into email and send the email. So on the user interface that we have built, we can see we have these two: generate the optimization plan and send the email. So we will be calling these two APIs here. So let's see how exactly we can build that. Okay, so currently this particular part is not built yet. So let's hide this particular one. I'm commenting that. So as you can see, we'll be using Fast API in order to build the backend. So from Fast API, we are importing Fast API and HTTP execution. So this is in order to start the Fast API instance. Then middleware in order to define some parameters. We'll see that shortly. Pydantic in order to define the standard data type and module format that we'll be importing. So we'll be using base module class from Pydantic and the email string basically in order to define the email format. So with this, it will make sure that it is accepting correct emails only. So that's where it is important. And base model is basically the class from Pydantic, which makes sure that you are following the standard. Let's say if you want to pass any input as a int, so it will be in int or not. That's what it will validate. So that's where we'll be using Pydantic datetime in order to pass the date. And from agent, we'll be importing run agent and home profile. So under the agent, if you see, sorry, we have built this home profile in order to pass the profile information, and as well as we have built this particular run agent in order to run the asynchronous call for the agent. So those two things we have imported. Now let's go ahead and build the app setup. So in order to start the app, we just write simple thing like app is equals to fast API, this one, and we can pass a title. So this is the title that we are passing, home energy saver API, and done. That's how we can start the application. So these details we are adding middleware. Basically, this is in order to allow origin star, meaning again this is not recommended, meaning it is allowing all the endpoints to consume. Then also, if you see all the APIs basically. Then allow credentials true, meaning it will allow browser to accept cookies and all other information. Allow methods, it will allow all methods like post, put, delete, all that information, get. Then allow headers, it will accept all the headers from the HTTP method. So it's for that purpose. And again, it is not recommended as we're testing it. So in lower environment, it's fine to use that. But in upper environment, we need to define specific values. Now, in order to start the application, we can use UVCon. So let me quickly add a function to run this. So under the main function, we are importing the UVCon and UVCon.run. We are running the application on the local host with port 8000. So we are exposing this application to 8000 port. Let's see whether it is working or not. Let me clear the screen. Okay, so to execute this, either you can run it with UVCon run app dot UVCon run app, and you can mention the port, or as we have already added this particular command in main function, you can just go ahead and execute the Python file, Python app.py. So it will start the application at this particular local host. Okay, just a sec. Okay, my other application is working. Let me just stop that. Okay. Okay, the 8000 port was busy. That's fine. So let's go ahead and follow this particular link. Okay, so let's see whether it is working. Okay, so it will not accept 00. So if it is not accepting 00, switch to localhost. Localhost, and the port is 8000. Okay, you can see details not found, but you can see the application is running. We are able to run the application because we have not added any endpoint. That's where it is not showing anything, but that's how we can start the application. Now let's start adding the methods. So for testing quickly, let's add the get method so that we can test. So we are adding the routes now. So the first route that we have added is app.get. So whenever we are adding forward slash, this particular route will be triggered, and this route is nothing but just returning the welcome message, and it will show the information. These are the routes that are available with this document, and a documentation log. So as we are using this Swagger, so with Swagger, if you add docs, it will take you to the Swagger page. Let's go ahead and save this, and let me start the app once again. Okay, let me go ahead and refresh. Okay, with just forward slash, it is taking us to this particular route. So this is our get route that we have defined. You can see welcome to the home energy saver API. These are the routes that are available. Currently, we are yet to add these particular routes. So let's go ahead and start adding those routes one by one. One more thing, in order to quickly test the application, the Fast API provides a Swagger page, and that Swagger page you can enable by just adding docs. So if you add /docs, that's what we have given here, it will take us to the Swagger page. So let's open that. Okay, you can see the Swagger page, and this is the GET request that we have, and you can go ahead and try it out this particular GET request. So currently there is nothing in this GET request. It is just returning the welcome message. So that's how you can execute it. You can see it is returning the welcome message. So that's the Swagger page, and we'll be using this in order to test the API. Now let's go ahead and build the route optimize energy one. So let me go ahead and add the code for that. Okay, so you can see we are adding a post method, and this post method is triggered whenever we are going to this particular route optimize energy. Summary we are passing it is generating the energy optimization plan. Tags it is agentic AI, we have just given tags. We need to define this optimize energy request. So let me add that. Now, as I mentioned, we need to define a Pydantic model. Okay, so we need to define this particular standard Pydantic model. So let me add that. So if you see, we are defining the optimized energy class, and which is inheriting the base model from Pydantic. So this will follow the Pydantic structure, where we are making sure that we are passing these details in the required format. So if the details are not available, it will pick the default. So all below are the default details, and household size and the appliance present, we need to pass it as list, and this one as integer. So that's how we are making sure that we are passing the correct format input. And again, we are given one example model config so that we can test the application on the Swagger page. So always make sure whenever we are building this particular APIs, you need to make sure that you are passing the sample dataset so that you can quickly go ahead and test whether it is working or not. Okay, so this is done. Okay, so as we have defined this one, let's go ahead and pass this particular optimize Pydantic class as a input. So optimize energy is accepting a request in the form of optimize energy request format, the Pydantic model format, which orchestrates the entire agent workflow and returns the structure output. So from this particular agent.py, whatever we have written, it is going to generate the final output, this output. And that is what we are passing here. So if you see profile, you are passing home profile. That is what we have imported it from this particular data model. And then run agent, again, we have imported it from this particular agent.py. And we are passing it the request that is coming from the user in the dict format. What's the issue here? Sorry. The dict method class is deprecated. Use model dump. That's fine. You can use it to model dump if it is not working. For now, it's fine. And then if it is not, then we are raising 500 exception, right? And we are returning the message as agent error, because this is the agent multi-agent framework that it is calling. So complete agent.py code that we have written, it is calling this particular route. This route is navigating everything to this agent.py and extracting the response for this particular user question. Let's go ahead and test that. Let me start the app or refresh the app. You can add -- reload, and in order to keep it running. Okay, let's go ahead and refresh this page now. Okay, so you can see on the page now we have added post agentic AI. This is the tag that we added, if you remember. And under this tag, you can see post method optimize energy. That's what we have given. So let's test it out. So the example that we added in the Pydantic model, if you see, this is the configuration that we have added. This one, model config. That is what is coming here. You can see appliance present, household size, latitude, longitude, all the information, this example. Now, in order to test this particular route, we need to pass this request body. So this request body is already added. So what we can do is we can click on try it out. This is the request body. If you want, you can change few details if you wish to. Let's say here we are passing 2. You can change anything. Let's say rate is 10 and good. Let's go ahead and execute. So it will go ahead and call the agent.py. So if you check now in the log section, it will go ahead and it will go ahead and print the logs. So whatever details that we have added in the agent.py, this particular run function, it will go ahead and execute that. Okay, you can see it has print the collector agent result, and then it has calculated the prediction and all that information. Let's go ahead and check. Okay, you can see it has generated the response. Summary: tomorrow will be cooler with the high 28 degrees Celsius, mainly clear. Then for air conditioning, this is the setting. All that information it has generated. The way we discussed here, it is generating this particular output, right? Summary, action, appliances. For each appliances, it is generating this particular recommendation. That's what we can see here. So this particular route is working. So meaning our agent.py is working fine, the optimize energy route. Now this route we will be calling on UI. So whenever on this user interface, whenever we will hit this optimize option, currently I have stopped the app. So whenever we'll hit this generate optimize plan, it will go ahead and call this particular backend optimize energy, and it will generate the energy optimize energy plan. Now next step is we need to add the email route so that we can send out an email. For that we need to build the email agent. So let's go ahead and create the file email agent.py, which is a separate agent that we will be calling individually in order to trigger the email. So for that, let me go ahead and add the code. So let's add this. So email agent.py, which generates a human-friendly email report using Microsoft Agent Framework and sends it via SMTP. So SMTP is a simple mail transfer protocol which we'll be using in order to trigger an email. So it is a library, Python library. You can see SMTP lib. This is the library that we'll be using. And then from agent framework, we'll be importing OpenChat client and the Azure AI credential in order to generate the email report based on the information that will be passing this particular information that it has generated. This information will pass, and based on this, it will generate the final report. So first of all, let me go ahead and add the secrets. So we are using SMTP server, again a standard server, port, again a standard port. Email sender, I'll be sending email from this particular email ID. You can change it as per your one. Email password I'm adding. This is not my email password. This is the one-time password that I have generated. Basically the token that I have generated. So in order to generate the token, you can go to this particular website. I'll attach that in the file itself. So https myaccount.google.com/apps password. You can go to that, and from here you can sign in with your application. And you can create one token. So you can see I have created one for home appliance. You can give app name and create, and it will create this particular ID for you. Right? I will delete this particular email password before I upload this particular video. So make sure you create your own and you're not using mine. Even though if you use this, it will not work. Okay, so that's what we have defined. And let me add under the readme.md, I'm adding this particular link. So you can pick it from the readme. I will update this particular readme later on. Okay, coming back to email.py. Okay, so let me go ahead and add the agent. Okay, so we are writing a function called get email agent, which is again in order to generate the email format using Microsoft Agent Framework. So again, we'll be using Azure OpenAI chat client. We are passing the Azure credential just like we did in the previous agents, and deployment we are passing this particular model name. Instructions we are passing, you are a email formatter for a home energy optimizer, and task is to convert a JSON into energy saving plan, include greeting, summarize weather overall context, list each recommendation, keep formatting readable, and do not include any sign off. And it is returning the body. So this is what it is doing. The task of this agent is to take the JSON that we have created, this particular JSON, and generate the final email. And that is what we are returning. In the return, we are just client.creating the agent and passing the instruction. Simple one, we are not adding any tool as such. You can add email send as a tool with the help of SMTP, but let's keep it simple for now. The next part that we are adding is to generate the email body with the help of SMTP. So we are generating this particular email body. We are planning passing this particular JSON, then the recipient name. So if you see, we are getting the we have created the agent object with the help of get email agent that we have defined. And for that, we are passing this particular payload where we are passing recipient name and the JSON. Recipient name is the one that user will pass, and the recipient name. Then give the model clear singleton input. So this is the user prompt that we are giving. Format this energy saving plan into an email. This is the recipient name, the plan JSON that we are dumping, and returning the plain text. And then at the result, we are just running the agent. So whatever agent that we have called, it will go ahead and use this particular format in order to generate the email. So for generating the email, we are just passing here the email recipient name, and so we are adding the recipient name, the JSON that we have created, and then we are running it. Simple thing that we have integrated. And at the last, we also need to integrate the signature. So as a signature, we are adding custom signatures, because if you see here, we have mentioned written only the email body and no signature. So custom signature we have given, best regards, Home Energy Saver AI agent. That's what we have given. Now, in order to send the email, we'll use SMTP. So for SMTP, we need subject, body, and recipient. That is what this particular thing will generate. If you see, it will generate email body plus signature. We are defining the subject, from, to, all those informations, and then we are just, with the help of SMTP lib, we are just reading this particular email. So for that, we are passing the email sender name information, email password, and the recipient information. And with the help of SMTP library, it will send out that email. Now the next part is, we just need to write this one function which will go ahead and integrate all these functions in sequence, so that it can go ahead and send out that email, and that function will be using in app.py for testing. So let's add that one call API. So we are writing a asynchronous function. Asynchronous, if you are not sure, it is in order to basically execute the function parallelly. If there are multiple calls, it handles that. So generate email and send asynchronous. So it is generating the email as well as sending it. So if you see body, it is first generating from the agent. Subject, we have hard coded it as your home energy optimization report. And then subject, body, and to email, we are passing to send email in order to send out this particular email. So that's the simple thing. Now, in order to test this, let me add one main function along with the sample data so that we can test it. Okay, so if you see, I have added this local testing under main function. We have added a sample plan. So the sample plan that was generated, this particular plan. So we are going to use this particular plan in order to generate the recommendation. So this is what we are passing. If you see, that's the plan that we have passed, sample plan. And then if you see asynchronous, we are calling it as a underscore demo, and just one function where we are defining the email. Now this is the to email. I have kept both email as same. So I'm sending email from this email to this email itself. You can change it if you want. Then we are just printing to whom we are sending it. And then if you see, we are calling this particular generate email and send a synchronous call. And we are passing a default recipient name as my name. And that's how it is returning that. And that's the result that it will opt in. And that's where we are running the asynchronous demo function. So let's go ahead and test this. For testing, let me interrupt this. And Python email agent.py. Let's see. It should work, and it should go ahead and send out that email. So sending test email to this particular email ID. Okay, if you see result, email has been sent. So let's go ahead and check that. Let me refresh. Okay, you can see I received this particular email 0 minutes ago, that okay, tomorrow will be cooler than average. All that information, everything is mentioned here. So that's how it is generating the email as well as sending. So we have utilized third agent in order to generate the email as well. So that simple it is. In order to use the Microsoft Agent Framework, you just need to define the function, and you need to define the agent instructions. And if you want, you can add the tools as a capability for the agent. Okay, so our this part is also ready. Now let's go ahead and build this particular route as well for the email sending agent. Now, first of all, we need to define the Pydantic class in order to define the standard structure. So let me add that quickly. So here we have defined for optimize route. Let's add it for email sending route. So for email sending route, if you see, we are using a class email plain request. Again, we are inheriting the Pydantic base model. We have defined plan JSON, which will be in the dict format. Email is a email in string format. Email string, we have already imported it from the Pydantic. So if you see, we have already imported it from Pydantic. That we have defined, and the name of the user, default is user. Now if you see in the model config, again the example that we are adding, so that we can test it on the Swagger page. So that's the simple example that we have added. Now let's go ahead and add the post request for email. So we are adding the email route here. So if you see app.post /email plan, summary is format and send email, and tag we have added it as email. And then we have written this function email plan, where we need to pass the request, And for that request, it will go ahead and call this particular generate email and send a sync function. So this function currently is not defined. So we need to enable this one that we commented out earlier. And now we are good to test this email as well. Let's save this and let's go ahead and run the application python app.py. Okay, go back to Swagger page. Let's go ahead and refresh. Okay, you can see we have added new tag email, and under email you can see we have a email route, email plan route. So let's expand that, and if you see, this is the sample schema that we have added. This request we can go ahead and execute. So in order to test this particular post method, let's click on try it out, and here let's pass a valid email. Okay, username, let me pass my username. Okay, so we have updated this one. Rest of the things, let's keep it as is, and let's go ahead and execute. So it will go ahead and execute this. So if you see response, okay, let's say whether we have received the email or not. The invalid character at JSON decoder. Okay, looks like some issue. Okay, let me refresh this. Looks like I messed up while updating the email ID. Let's go ahead and try it out. Okay, username Sandesh and execute. Okay, now it is working. Looks like something messed up while updating the email ID. So you can see now it will go ahead and hit to this particular endpoint that we have built, and it will go ahead and send the email. So if you see, okay, email sent successfully. Let's check on the email. Let's refresh. Okay, you can see we have received this email again 0 minutes ago. This is the email that it is generated. So it's working now. The all the two APIs that we have built, the one for optimize energy and the second for email plan, both are working fine. So let's save this, and that's what as we discussed on this particular application. Now this part is done. Generate optimize plan, send email is also done. Now it's time to build this particular beautiful user interface, where on the left side we will have this particular panel where we can feed the user input information. We can pass the email ID, user recipient name, the information that we have hard coded in the code that we can pass from here, and that's how we can go ahead and generate the energy optimization plan. And so it can be used for any personalized home recommendation by removing those hard-coded values. And in this video, I'll try to cover this particular user interface now. But the deployment of this particular application, if you guys are interested, just let me know in the comment section. I'll try to cover the deployment as well in the next upcoming video. Okay, so now the part is to build the user interface. So we'll be using Streamlit. So let's create a Streamlit app.py as a file. And here I'll be writing this particular Streamlit app code. So again, we no need to focus much on the application side, but that's fine. Let me go ahead and add the code for this, and I'll just walk you through this particular code. Again, as it's a front-end code, so there will be a lot of formattings and all those stuffs that we have added, but we can skip those parts. So Streamlit app.py, where we are adding a UI for home energy saver, the agentic AI. And these are the two requests that we have written. So first of all, we are importing the dependency. We are checking whether Plotly is available in order to plot the gauges that we have added on the user interface, these two gauges. Base URL. Now, in order to make sure that this user interface runs, we need to make sure that the backend is running at this particular port. So currently we have passed this particular port. Again, as a standard industry practices, we need to save these as a environment variables, and from there we can use these particular endpoints. So we know that we need to hit to these two endpoints, the energy optimization and the email sending out of this. So for that we need a base URL. So in one terminal, I'll keep this particular app open, app.py that we have tested, this one. And in the Streamlit, we will run the Streamlit app in another terminal. So we're checking, we have given the appliances choices. We have added the default appliances choices. As I mentioned, this part you can remove it and you can make it dynamic as well. For the application where I have using the past CSV information of the past consumption, in this CSV, I don't have the records for, if you see, I don't have the records for fridge, O1, all those information. That's where I have removed those categories. And so because of which the second agent that we have built in order to find the final recommendations while comparing both input like the CSV versus the predicted one, it will not have the correct information to compare. That's where I have kept only the categories for which I have the data available. So you can add the data here, and that's how you can enable the remaining categories as well. The thing that I mentioned on the UI, we have default added these categories, you can change it. So that's what you can go ahead and change at this particular part. Time zones, couple of time zones that we have added. You can add those as per your request or as per your necessity. Helper functions, again, we are writing a helper function in order to hit to these routes. So you can see backend URL plus optimize energy in order to predict that. And if you see, we are just sending a post request along with the payload. Similarly, post email plan, backend URL plus email. This backend URL meaning the localhost, this particular path on which the backend app is running. And similarly, we have created the post email. Then we have written one function KPI from plan. So for each plan, basically it finds out the expected kilowatt hour saving and the expected cost saving. So the information that it is returning here, the expected one, estimated saving, cost and energy, that is what it is calculating. So that's how we have written this particular function. Then render gauge, the gauge that we are plotting on this screen, these two gauges, that's where we are using this particular gauge function. Again, you can go through this particular code. Again, it is a code that we have written just to plot those particular two gauges. And basically it uses plotly, and with the help of plotly library in the Python, it is helping plotting those two graphs. Then nice rupees, it is just to convert it into rupees. Geocode city in order to identify the longitude and latitude, because if you see on the user interface, we are passing location as a city in string format. Out of that, we know our weather forecast API needs to find out the geolocation. So that is what we have added it here in order to get that. Show action card is the one that we are showcasing on the UI. This particular part, appliance and the recommendation for each. So if you see, we are iterating for each plan, and that's how we are calculating. For each of plan, we are calculating the expected kilowatt hour saving, the estimated saving, the recommendation appliances. That is what we are generating with the help of Streamlit code. Show weather, we are showcasing the weather information. So if you see here, we are showcasing, once we click on generate optimized plan, here there was one line about the city that we have selected. So that is what we are passing. Then we are showcasing the forecasted values. Then decorate header. Now this is in order to set up the page and all the border information, margin of the page. Streamlit layout, again, this is for that, like say the title of the page, background, all that information we are showcasing here. How should my background look? The button color, particular agentic AI, whatever we are writing, everything we have planned. So this code is for that. Now then we are building the side panel. So this sidebar we are building where we can pass the input parameter, we can pass household size, all that information, latitude, longitude, the default values that we have added. You can see default locations that we have added, all that information we are showcasing. The tariffs we are selecting. Okay, then the main actions, the button state. So basically here we are checking whether the email has been sent or not. So this particular information, to print that, we are calling these particular that's where we have written this code. Then control rows, we are checking how to once clicking on these particular buttons, how exactly the control flow will work. So once the generate optimization plan is clicked, then only this particular button will work. Okay, so we have checked these two buttons now, generate optimization plan and send plan by email. So on hitting these two buttons, we are calling these respective APIs. Okay, so that's how it is. And then all that information that we have added, we can go through this code. It is again very simple. And we have integrated some session states and all the supporting information that we have added. So the main thing is to define these two buttons. So here we have defined the buttons, and then we are running those buttons. So on running those buttons, if you see, we are getting the geocode, city information, latitude, longitude, passing it, and then we are preparing the request, and that request, then we are sending it to this particular post request, the post optimize energy. We are passing this request and generating the plan. And similarly, we are doing it for the email. And then we are plotting these gauges and all that information. So if you see, this is the trigger workflow for sending the email. So same thing are there. And at the last, we are adding these markdowns. This one. Okay, so we are done now. we have built the complete end-to-end application. Now it's time to run the application. So as this particular application, backend application is running on localhost port 8000, we'll keep it as is. Let's add a new terminal here. And here we'll go ahead and run the Streamlit application. Now the command to run the Streamlit application is Streamlit run, name of the file, Streamlit app.py. Let's run this and it should start the Streamlit app. Okay, you can see it has started the Streamlit app and cool. So the application is working. Let's see, we'll test it quickly. So household size, let's select 5. Location, let's keep it this time Delhi. Time zone, let's keep it as is. This one, let's keep it 10.5. 8. Peak start time in Delhi is, let's say, 8:30, ending on this time. Email address, username, let me pass. And let's click on generate optimization plan. So if there are any errors, we'll go ahead and fix those. Hopefully it should work. If you see, it is using location Delhi, India. It is calling the optimizer backend API. Let's see now. Fingers crossed. Cool. Okay. You can see it is working fine. So it has generated the recommendation. We can save close to 7.41 kilowatt hour, close to 7.5 units, and close to 65 rupees per day. So air conditioning, if you see the recommendation, switch off as temperature are forecasted to be cooler at 25.3 degrees Celsius. Already in the daily, the temperature has already drastically dropped, and that's where it is recommending not to use AC, and that's where you are saving a lot of cost. Washing machine, there are no specific recommendations for those. Heater, it is saying that, okay, you can avoid using the heater because again, the temperature is not that too as well. And the computer. So yeah, that's how it is working end to end. So yeah, I hope this video was helpful for you. And I hope you understood each and every step that we have followed in order to build this particular agentic AI application. So if you have any questions related to the code, related to the diagram that we have discussed, or if you are facing any issue while building the application, please feel free to let me know in the comment section below. If you are new to the Microsoft Agentic Framework, MAF, then I have already created one video. You will find the link in the description below. Please go ahead and check out that. So there I have covered the basic way of building a simple agent with the help of Microsoft Agent Framework. And also, if you are interested in understanding more about the agentic AI, please go ahead and explore my YouTube channel. I have already covered a lot of details on with respect to agentic AI like LangGraph, AutoGen, and many more. Also, if you are interested in understanding the Azure functionalities, how exactly the Azure Foundry work, and if you are interested in understanding how exactly you can build the agentic AI application with the help of Azure Foundry, then I already captured it as part of my Udemy course. You will find those links available in the description. So yeah, I hope this was helpful for you and you got a thorough understanding of building this agentic AI application. Feel free to reach out to me and drop your questions in the comment section below. So with this, let's end this particular tutorial for now. And in the next session, definitely I'll try to cover the deployment part as well if you guys are interested. So please let me know your interest in the comment section. Thank you so much, and I'll see you soon in the next interesting video. Thank you.